class. We'll try to go over the handout questions today. Number one. So let us see. We have 5, 7, and x with the length of the three sides of the triangle. So from the triangle inequality that we have learned, we realize that x basically can be between two numbers. Sum here, which is 5 plus 7, and then difference, 7 minus 5. Meaning we realize that x is between 12 and 2. Alright, now, so we realize we are looking at the perimeter of the triangle, not the value of x itself. So how do we get the perimeter? In fact, since we have two sides, such as 5 and 7, and along with x, in order for us to get the perimeter, P essentially is equal to 5 plus 7 plus x. In other words, not only having x, and then I'm going to give some space here, having 2 and 12, what we figured out previously, what we have to do is we need to add 5 and also 7, just like here in this problem. Then we will not only do this one, this part of the inequality, but also here and also here. Hence, we will end up getting 2, 5, and 7 will end up getting 14. Will be our lower bound for our perimeter, and then upper bound will be 24. So therefore, this will be our final question, a final answer. Let us look at number 2. Now, in this case, we have 10 x and x plus 4 with the three sides of the triangle. Now, then, as we mentioned before, we could apply the same principle. By the triangle inequality, we could realize that x plus 4 could quite possibly be the largest side, which let us know that the other two has to be the sum of the other two has to be greater than the last one. Now, in this case, as you can see, as you subtract x from each side, then you will realize that 10 is greater than 4, which is true at all cases. So in fact, when this one is greatest, then it will always make sense. Now, but on the other hand, how about 10? What if 10 is the greatest? In other words, then 10 would be the 10 has to be less than sum of x plus 4. Now then, in this way, we get to realize that 2x plus 4 has to be greater than 10. Now, as we subtract 4 from each side, we realize 2x must be greater than 6. In other words, by dividing it by 2 on each side, we get x has to be greater than 3. Now, that means as long as x is greater than 3, then this inequality will be always true. So that's it. That's all. That's our answer for number 2. Let us go for number 3. The length of two sides of triangles are 4 and 5. Find the largest area. Okay, all right. Now, if the two sides are 4 and 5, one of the easiest thing which you can think of would have been 3, 4, 5 triangle. But that's not what we're looking for here. I'm asking for to find the largest area of the triangle. For example, what if you were to say this length is 5, and I'm going to just use the red, and the other length is 4. So 4 can be this way, as an example. That is quite possible. Now, or it can be here, or it can be here. It can be anywhere we want it to be. It can go around anywhere we want it to be. Now, the question is this: how do we find how do you find the area of the triangle? Area, as we know, it is 1/2 base times height. Now, given that, what if this is base? How can we make the largest area? That means we need to increase the height as much as possible. Going back to the demonstration here, under what circumstances would you have highest height? Will it be right here? Or will it be right here? In fact, we will have the highest height when the other side is, in fact, perpendicular to our base. Like this. In other words, this can be, as you mentioned, 5, this can be 4, and yes, the third side in this particular case would have been something like this, which results in the area to be equal to 1/2 base times height, which is equal to 10. That is our final answer. Right. Now, number 4. In an isosceles triangle has length, okay, 4, oops. So the length is 4 and 9. Okay. Now, because it's an isosceles triangle, let us think about it. The third side could actually be either 4 so you could actually have 4, 4, 9, but can this be a triangle? In fact, this will violate the triangle inequality, hence this will not be possible. That means 4 cannot be repeated. In other words, 9 is the only one that can be repeated. But let us look at it then. We are looking at an isosceles triangle. Where one side is 9, the other side is 9 also, where the base is equal to 4. Now, given that we want to find the area of the triangle, then of course we need to figure out what height is, h. But as we have learned that in an isosceles triangle, the median is also an altitude, which gives us this small line segment will be 2, and this one is 9, and if we call this one as h, then we get to realize 2 squared plus h squared equals 9 squared. The famous Pythagorean Theorem. Then we get to realize that h squared will be equal to 81 because of 9 squared, but because of 2 squared we will have to subtract 4, which will result in 77. That is h squared. That means our height will be square root of 77. Now, given that how we find the area of the triangle, then area of the triangle here will be equal to 1/2 our base, which is equal to 4. Our height, which is equal to square root of 77. Then we get to realize our area becomes 2 square root of 77. Becomes our final answer. All right. Now, number 5. I'm sorry, this is actually number 5. Somehow I was going to write it like that. In triangle ABC, the angle C is the right angle. Now, that means we are looking at the right triangle here. So I'm going to try to draw the right triangle. Now, angle C is the right angle right here. And D is on AB. Now, but the CA is 5, so I'm thinking I'm going to put this one as A, and then this is 5. And CB is 12, so therefore I'm going to put this one as B, and then this one is equal to 12. And as you mentioned, D is on line segment AB, so D can be somewhere around here. Now, the question is find all possible values of CD. All right, now, soon as you realize that this length is 5 and this one is 12, then you get to realize that line AB will be equal to 13, and we can easily do that since it's a right triangle right here by using the Pythagorean Theorem, and then you can actually try to use this equation. 5 squared plus 12 squared must be equal to AB, the length AB squared, and you will realize that this will be true. Now, but why is that important? Now the question is, find all possible value of CD. That means we are looking for the minimum and also maximum. What will be our minimum? In fact, minimum can be easily done it this way. If this is C and this is D. Now, of course, as you D is not a one particular fixed value, so in fact we can move around along this line on AB to figure out what the line segment CD would have been. Now, as you can see, between the point and a line, the shortest distance will be, or shortest distance can be found when the line segment is perpendicular. In other words, knowing that this is 13, and we realize about the right triangle. In fact, this can be base times height, or if while 13 is the base, then CD can be our height. So using that, what we can do is this. To find out the minimum CD, what we can do is this. Area will always be equal to each other. In other words, 1/2 base, which is 12, times height, which is equal to 5, that must be equal to base, which is 13, if you consider AB as the base, then CD will be the height. Now, then when you realize when you calculate the left side, it will be equal to 30. On the right side will be equal to 13 over 2 times CD. Now therefore CD then will be equal to 60 over 13. In fact, we have to remember that that will be the minimum. Then of course, as we talked about it before, as D moves along this line AB, when are we going to have the longest side? In fact, longest CD will happen when D is most away from this particular place. Okay, more than towards A, I guess. If you move towards B, then it will be the longest. In other words, the longest meaning the maximum. Let me try to talk about this one. Maximum, in fact, has to be when D is near B. In other words, okay, wait a minute. Since D is on line segment AB, the farthest where D can be is if D is on point B, then we realize CD will be in fact equal to CB, which is equal to 12. So in fact, all possible value for CD has to be less than or equal to 12, but greater than or equal to 60 over 13. And that is it, class.